Graduation. An investigation into the mortality experience of a sample of male student population of a large university has been carried out. The university authorities wish to know whether the mortality of male students at the university is the same as that of males in the country as a whole. They have drawn up the following table: age x, number of deaths expected, carry out an overall test of the university authorities hypothesis, stating your conclusion. So let's solve this. Okay, so this is the question you have, and this is the answer sheet. I have it open here. So let's do question 1. Question 1 is here is, first we have H naught is mortality of males at university follows that of a country as a whole, and alt equals to H underscore 1 is mortality of males at the university does not follow of a country as whole. Okay, so this is there. Then we need to find the chi-squared test statistics. So you can just write chi-squared test statistic is, now we'll take these values. First write chi. So how did I write chi? / chi to the power 2 underscore brackets square brackets underscore 6. So chi square 6 degrees of freedom is equals to backslash of sum actual number of deaths. So this you can write theta x also, what you write, actual number by expected deaths observed by expected square divided by expected deaths. So this is there. Okay, and summation is on obviously on the whole thing. So coming down, alt equals to, so now we'll continue 13 minus 10 square divided by 10 plus 15 minus 12 square divided by 12 plus 14 minus 14. So you can see I am taking values just from our table because it's given to us. 14 minus 14 divided by 12, 14 plus 20 minus 12 square divided by 12 plus 12 minus 8 square divided by 8. Just changing this 12 and plus 8 minus 5 square divided by 5. So this was there, and solving this you get 10.783. Okay, from tables we have probability of chi-square 6 greater than 12.59 is equals to 0.05. So for 5% significance level the value is equals to 12.59, and for 10% significance, so just copy this, that for 10% significance level the value is 10.64. Okay, since as our probability lies between 0.05 and 0.1, then there is more than 5% probability of obtaining data like null hypothesis. Hence we have insufficient evidence to reject the null hypothesis at okay at 5% significance level also you can write, otherwise you have written already 0.051. Next question. In this question we'll cover all of the tests almost. So question 2, let's come to this question. So this question says an investigation into the mortality of men engaged in hazardous occupation was carried out. The following is an extract of the results. Okay, so we'll use this. Following age X is given to us, initial exposed to risk EX, observed deaths theta X, and Q hat X is given to us. It was decided to graduate the results with ELT 15. The formula for the graduation was Q naught X is equals to 10 QXS. So where obviously QXS is the standard tables mortality which you need to use, and from ELT 15. Using a test of overall fit of the graduate rates tests the hypothesis that the underlying mortality of men in the hazardous occupation is in accordance with the formula given above. So first obviously we'll write our H naught. So H naught is equals to the underlying mortality of men in hazardous occupation is in accordance with graduation formula. Okay, this is there, and obviously then H1 is just the opposite of this. Copy this, paste this, is not in accordance with the graduation formula. Okay, I have currently zoomed in, that is I have to move just a bit of this. I will not have to move then. Okay, next is now we have to test the goodness of it. So obviously chi-square test statistic, chi-square n, chi-square goodness of fit test. We're not writing n because we have to decide our n here in graduation. So goodness of fit test is equals to zx square is equals to backslash theta underscore x minus e underscore x q naught x. Now you can obviously, what you can do is, if you are using this formula a lot, then save this formula. How to save a formula and create shortcuts for this is shown in a video in YouTube. Follow that please. SQRT of e underscore x q dot x and underscore x and 1 minus q dot underscore x. So this is there, and then this becomes our formula zx square. Okay, since graduated rates are small, so then our zx square formula becomes, just click on this and remove the portion you do not need. Okay, so this is the formula for us. Now what we have to do, we have to create a table. We do not have ex into q dot x value. We have to calculate q dot x, that is 10 into qxs. What I will do, since I have to make a table of theta x, q naught x and ex into q dot x and then zx, I will make that in Excel and then I will bring that to Word. Okay, it is easier to make tables in Excel. If you want to give heading in Excel, that is fine. Otherwise, you can give heading in Word also. I'll give headings in Word only because it is representable. I'll just write the ages 30, 31, and you can just add +1 to this. Come down till you need values till 38. If it's extra, please remove it. Okay, 30 to 38. Then we have theta x. The values is 12, 14, 16, 9, 11, 15, 10, 16 and 17. Okay, then we need to have Q0 x. Q0 x, again from the tables you need to pick this value. So just pick the values from the table. Zero 0.0106, 0.0116, 0.0127, 0.0138 and 0.0149. We were told that EX into Q0 x we need to calculate. Again, EX values are given in the PDF as 950, 1200 and so on. So we'll just write the values for EX so that it's easier for us to calculate. 950, 1200, 1200, 900, 1000, 1100, 800, 1250 and 400. We need to multiply Q dot X into EX. So these values will get 8.645 and so on. And then you have to calculate ZX. ZX is nothing but theta x, which is this minus this. Just put brackets in front and then divided by SQRT of this value. Right? Control D. All of these 4 decimal places is enough. And now what I'll do, just give a border to this with an extra row, obviously, because you haven't given the headers. Okay, so Control C, copying this table and pasting it in Word. Okay, once you paste this, it's a normal table without showing that any calculation is done. You can just normally do this and just write this is the age. Then here it was your theta x, so alt equals to backslash of theta underscore x. This gives me theta x. Alt equals to, this was backslash of q backslash of dot space x. Here it was alt equals to e underscore x, and then here it was equals to e underscore x into q dot underscore x, and then alt equals to zx. Okay, you calculated this. We missed out a column which is zx square. Okay, you could have easily calculated zx square also here. Then you don't need to calculate this, but now if I calculate, I won't be able to add this. Just do not use all the values from till 4 decimal places. It's okay. Control C. What I'll do is I'll add one column, insert column to the right and paste the values. Trying to paste. Control Alt V. Do just trying if I can do this in a format. No, it's not coming. We could have done this earlier, created a table earlier only, but now it's difficult to, either I can do again. One thing is copy the table again instead of wasting time. But remember, in exam, do all these steps in Excel in one go. Okay. Now it is there. Something is going wrong. Anyways, I've showed you all. So what you can do is just write the value from here, sum karke, that sum of zx square is 24.533. So alt equal to z underscore x to the power 2 is equals to 24. B10, this value is a bit wrong. 400, 0.0419, 5.96 will not come. D10, 400 into 1400, this is, that is why it is coming wrong. Minus 0 point, just make these changes. Zero 0.8451, 0.7143. Okay, sum of this is 4.870, 4.806. Okay, so chi-square value is 4.8076. So if you see for degrees of freedom, first you have to lose, we lose 1 degree of freedom for parameters in the link function, and 1 to 2 degrees of freedom for using standard table. Okay, so you can either do for chi-square 8 or chi-square 7. I am doing for chi-square 7. So alt equals to backslash chi-square underscore 7 is equals to, from the tables, chi-square 7 is 14.07 for 5%. Since our test statistic is less than critical value, so therefore we have insufficient evidence to reject H0. Okay, I took some time because I made some silly errors. Obviously you can do this easily on Excel and paste it properly if you know from the very first time you calculate zx square also here in Excel. Next part is coming to the question. Test the graduation using two other tests which detect different features of graduation. For each test you should apply for each test you should apply 1 second. State the feature of the graduation in which it is designed to carry out this test and state your conclusion. So we'll do this, carry out this test and state the first is two others, and first is science test. So I'll show you all the methods, whatever you all can use this. First I'll show science test. So for science test you should feature is the science test checks for overall bias. Okay, that is whether graduated rates are too high or too low. Okay, so means basically there should not be any bias in the data. For science test statistic is equals to TS alt equals to 2 into probability of n greater than equals to 6, which is equal to 2 into 1 minus probability of n less than equals to 5 which is equals to 2 into 1 minus 0.47461 or equals to 0.5078, where n, what is n? Where n is the number of positive deviations which follows binomial 9, 0.5. Okay, and conclusion is, finally we have to show 3 parts of conclusion. Just since p value is much greater than 0.05, greater than 5%, we have insufficient, there is insufficient evidence to reject H naught. Okay, and then so now suppose this part only I'm showing you a lot of tests. The cumulative deviations test, I'll show you all the 4 tests so that it is covered in this one sum. Cumulative deviations test feature is checks for the bias over the range that is being considered. The CDT checks for the bias over the age range to be considered. Okay, and then feature is this, then test statistic is equals to backslash of summation of backslash of theta underscore x. Now come out of this summation minus backslash of summation e underscore x q dot space x, coming out of this divided by backslash of summation backslash of sqrt backslash of summation e underscore x q dot underscore x space. So this is the test statistic for this. You can increase the size obviously, and then we have our values. So alt equals to, this value is equals to 120 minus 112.105 divided by SQRT of 112.105. Now again, do not apply these on calculators. Save your time. You already have an Excel which we haven't closed, and we have the values for EX into Q naught X. So you could have, this is Z, so this is the value for EX into Q naught X. You can just sum it up. See, this is 112.05, and you have the values for theta X also, which is this, and which you can sum up, which is 120. Okay, and then put it directly here. So do not need to calculate and so on. Okay, you can get your values directly from the Excel sheet and put it here. Okay, and conclusion is, since the values first, this is a two-tailed test, and H naught says the data should come from normal 0,1 distribution. So at 5% significance level, the critical values are alt equals to plus minus 1.96. Okay, so since our test statistic lies between the critical values. Therefore, we have insufficient evidence to reject H naught. Okay, and then finally next test which I am doing is grouping of signs test. So grouping signs test is for clumping deviations of same sign. Checks for clumping of deviations of same sign. Okay, test statistic here is alt equals to n underscore 1 is equals to 6, n underscore 2 is equals to 3, and g is equals to 1. So where n1 is equals to positive deviations, n2 is equals to number of negative deviations, and alt equals to g is equals to number of groups of positive deviations. Okay, so this is there. Since from the tables critical value is equal to 1, which is equals to g, we have insufficient evidence to reject H naught. Okay, and conclude that graduated rates are not consistent with underlying mortality. Next is last individual standardized ISD test. So for ISD test we'll do, first we write what does it checks if there are any excessively large deviations. There are any excessively large deviations. Okay, again you have to do only 2. I am showing you all 4. So we have excessive, we have to find the range, we have to find the observed, and we have to find the expected values here also. So again here also I'll draw a table. Okay, so say the table is like this, which don't need anything, we'll do it. So range, the ranges are -3 to -2. This is very important. Okay, these ranges which remains fixed for every ISD, -3 to -2, -1 to 0, 0 to 1, 1 to 2, and 2 to 3. Okay, you don't need these extra, so you can delete. See, delete, you have delete columns, and then you range observed and expected. So observed between -3 to 2 is 0, then from -1 to 3, 4, 2 and 0. So these are the values we have, and this is 0.18, 1.26, 3.06, then we have 3.06 again, and then we have 1.26, and then we have 0.18 again. So this is the values expected. All values will lie between -3. We have not shown the ranges, minus infinity. Okay, and therefore you see, since we have no large deviations here, you can see there is no large deviations. The biggest of an absolute value of 1.2779, or the observed values look reasonable, and say, so again you do not have any reason to reject the null hypothesis that the graduated rates are consistent with the true mortality rates. And okay. Okay, so these are the types of tests to do. ISD will make a table. Remaining any calculations you can do on Excel and paste it here. Just make sure your Excel has a border in it. You can give the headings here in Word only, no issues, and do all the calculations in Excel. Thank you. 30 minutes.